Now I want to introduce the interface to the software. On the right hand side there's a panel like a maneuvering panel with engine order, thruster and rudders and others. And all the measures which I do here can be immediately shown. For instance, if I move the rudder by 15 degrees, then you see immediately this is the outcome. So now it's 1, 2, 3, 4 minutes of shapes. This can be enhanced if I do it with 6, or for the maximum 24 minutes ahead, then you see the change of the ship. So maybe we should put it to 6 minutes. So you see immediately the effect of these maneuvers. And you can also change the rudder, for instance, for 10 degrees, and you immediately see the results of this one. In the center, there's the display of the results, and we can move the ship shape along this already predicted or calculated maneuver. So you see, this is the ship shape, which is moving through the maneuver, and all the information here, for instance, heading, course over ground, of the actual position can be shown here with the navigation, and also here with the controls on the part. So this panel is for the initial settings, and this panel, and on top, it's for the data acquisition on this specific point. We also could set a maneuvering point here, and then we can add another maneuver. So the different maneuvers can be shown here. For instance, this is for instance 35 degrees. This is what you have in your wheelhouse poster or maneuvering booklet, but you can do any other maneuvers here. And you can also do it with different speeds. So now it's for full ahead. If I go only with slower speed, then you see what happens. Nearly nothing. The track of the ship will be nearly the same, so the speed effect is not that high. What you also could do is you could show the pivot point. So if you go to the chart settings and you see the pivot point, shows the pivot point vectors, then you see the speed vectors in transverse direction on the stern and at the bow. And if you draw a line between that, then you have here the pivot point. So it's located close to the bow, what we all know. The idea would be to think how it's changing for other maneuvers. So this is, for instance, with, let's say, for 10 degrees of rudder. This is the shape, and you see that the pivot point is moving, as we know, in this direction, going to the bow, direction of the bow. What happens if you do the same maneuver, but now with a thruster? We could set the rudder to 0, and instead using the thruster, going maybe the same. We are too fast, so we have to go a little bit slower. So maybe this is about 4 knots. We do it a little bit more for more shapes. So what you see here is the pivot point is located more to the aft. So if you look onto this position, the outcome of this one is that, of this effect is that the shapes of the ship are nearly lined up, so no big swept paths anymore. If you want to really be using only a small maneuvering space, then you should better go with your bow thruster instead of the rudder. So again, if you use the rudder instead and no bow thruster, then you see the swept path, because of the drift angle, is much more bigger. What you also could use is, I switch it now back, split rudders. So split rudders, split engines. So we split the engines. One engine is going astern, and one engine is going ahead, like this. If you use a rudder then you see, oh, the turning circle is much more smaller than if you use both engine in sync mode. So you can do a lot of maneuvers much more better to do a very, very small turning circle with split engines. You don't have the information from the wheelhouse poster, but here you can have it. So what we can do with this software is also to for instance, for stopping, if we go with both engines ahead, maybe full ahead, it's equal to 22 knots. And then we move the ship a little bit from the initial point a little bit forward, like this here. And then I say, okay, from here I will stop the ship with full astern. So we focus now on this position and we go with the engine to full astern. Then you see the ship will only move until here and then it will stop here. We can check it out. Okay, here the ship has only 2.5 knots if you go a little bit further, so here it's stopping. Can we reduce the stopping distance? Yes, we can. For instance, using the rudder additionally. You see, oh, the advance will be much more smaller. Even if you desynchronize the rudder and you put one rudder in this direction, the other rudder in this direction, then you see the stopping distance is much more smaller. So any idea you have on the maneuverability of your ship, you can use it here and try it out. What you also could do is to maybe instead of stopping the ship, doing another maneuver, maybe for man overboard, instead of stopping the vessel, you go with full ahead. It's not suitable for a passenger vessel, but we will try it out with synchronized rudder to go maybe to 35 degrees. Oh, it's not good for a cruise liner because we go up to higher roll angles. So maybe we do the maneuvers with 15 degrees. Normally you would do this maneuver in a way, I will switch off the pivot points because it's a little bit distracting. So pivot point vectors off. So you would go for a Charno turn, for instance, to 240 degrees. We are now at 213, so we move the ship a little bit further. Oh, this 250 is too much. So maybe here, 240 degrees. Here we set a new maneuver point, like this one. And here we can switch the rudder, maybe to minus 15 degrees to stop turning, like this one. This would be the effect. Then we would move the ship up to a certain position where we could switch the rudder to a midship. So here, for instance, we have a rate of turn already to the other side. We move the ship a little bit to stop it up to here. So maybe we switch it here to rudder midships, maybe a little bit further up. Like this one, so we have to line up the ship here, and then you see, okay, this would be sort of a return maneuver in case of man overboard, but normally we would like to have the ship a little bit more to the initial track to see the person in the water. In this case we could switch to an edit mode, for instance, to do the turning maneuver here a little bit later onto a bigger, so we could edit this part and we go to maneuver point number 1. So the focus is here, and now we can let the ship go a little bit further ahead up to here. Then you see, okay, the whole maneuver is switching more to this part. Then we go to maneuvering point number 3, like here, and here we go also a little bit further. So you can shape the maneuver in a way as you like it. and then you can save it as a maneuvering plan, and you can discuss it or change it. So you can jump back and forth between these different positions. And this is what we call developing a maneuvering concept. This only explains the principle. We will do that for a real maneuver a little bit later. So this is for one ship. For instance, these are Ida Blue. We could also use other ships. In this case, I had to reset the maneuvering plan to prepare for a new ship. And here we can use, for instance, another ship like, now we have many here, Queen Victoria, for instance, in this case. So immediately the interface changes to azimuth thruster ship, and so we can do the maneuver with this one. So any of the ships in the database can be used immediately. Okay, this should only explain the main principle. Further application will be shown in a different movie. Thank you very much.